Okay, so welcome to part 13 of our Euclidean geometry, and this is just a consolidation activity where we're trying to look at everything we've done so far under Euclidean, from angle, talking about angles, after talking about angles, talking about the sides, theorem 1, theorem 2, theorem 3, how to prove all those things, just putting everything together. You would find this activity on page 205 of your textbook so that you can work with me. Page 205 of your textbook. Okay, look at the first question. In triangle PQR, PQ is equal to PR. And I've told you that. Did we do this? No, we didn't. We didn't do this question. Did we do this question, guys? It was not this one. No, it's not this one. It looks similar. All right. We didn't do this question. Okay. PQ is equal to PR. PQ. All right. PQ is equal to PR. You can't see the board. All right. BB says she can't see the board. Is it everyone who cannot see the board? Can you guys see the board? Which screen am I sharing? Can you see the board now? Okay, all right, lovely. Portia, can you see the board now? You also said you cannot see the board. Can you see the board now? All right. Look, guys, it's either you do two things. It's either you check my camera or you use the board. You can actually click my camera if it's clear enough for you. Then you can see the whole structure on the wall. All right. I still can't see. I think you need to do something, or just touch Crazy Physics on your phone. Maybe the camera can then come through, because you could either view from the camera or you can view directly from the board. Quickly, Isa, so that we can get on. Quickly. All right. Okay, reset it, but I need to carry on now. I'll be slow, so you be fast. All right. In triangle PQR, PQ is equal to PR. Okay, lovely. And STRE is a parallelogram. STRE is a parallelogram. What do we know about a parallelogram? All right, so we know that this will therefore be parallel to that. All right. And this also would be parallel to that. Good. If Q equals to X and P is equal to 2Q, angle P, is it okay to say this is 2X? Is it okay? Do we agree that that is 2X? If PQ equals to X, calculate the sizes of the angles of STRE. All right, lovely. Now, hold on, guys. Yeah, okay. Now you can see, I'm glad. Look at one thing they told us. One thing they told us is this. I'm just extracting this triangle. P. Please follow the information one by one and then interpret. They told us that PQ is equal to PR. PQ is equal to PR. What does that tell you? Can somebody just talk to me quickly? What can you figure out here? What type of triangle is this? What are the properties of this triangle? Somebody quickly. You can either unmute yourself. All right, good. You can. Okay, Isa says isosceles triangle. But what does that tell me? What does that tell me? Two equal sides, lovely. Okay. I don't want us to use the word isosceles though. All right. Two equal sides. Two angles are equal. Now, Tasmia, Two angles. Oh, Amara even makes it better. Angle Q is equal to angle R. Beautiful stuff. Angle Q. Angles opposite. Thank you. Now you're speaking Euclidean language. Angles opposite equal side. So, if this is x, do you agree that this would be x? Amara told me perfectly. Angle Q equals to angle R. And we are given that this is 2x. What do you then think? Can you please calculate the value of x for me? And I want everyone giving me answers. Calculate the value of x. What do you think x would be? What do you think x would be? Matthias says 45. Can somebody confirm that answer? Sugra says 45. Okay. Can somebody confirm that that answer is wrong? Oh, you are all confirming 45. Are you saying they are correct? But I say they are wrong. Anyone who joins me in saying they are wrong? That the answer is not 45. Shoaib, you're also saying it's 45. I disagree. The answer is 45 degrees. All right, 45 degrees. Just put in your legs. 45 degrees. Good. Somebody's saying, how did we get... Yeah, it's not 45. It's 45 degrees. Okay. Now, somebody's saying, how did we get 45? We can then say 2x. Okay. Because 2x plus x would be equal to what? 180. And what is that? Angles in what? Remember reasons? Angles in a triangle. Alright, therefore 4x would be equal to 180. And x will be 45 degrees. Beautiful. So already we have 45 degrees. But remember, guys, you need to give me reasons while you were saying angle Q. We actually missed a point. Angle Q is equal to angle R. And that's what you gave me. Angles opposite what? Equal sides. That's the reason there. Remember, Euclidean is a statement and the reason. Alright. Remember, we're looking for all the sizes of the angles. Do we have the first one? Yes, we have 45 here. Lovely. Which angle would you like us to calculate? What do you think? Which angle can we calculate? Which angle do you think we can calculate easily from here? S2. Amara says S2. Okay. Isa says E2. Alright. E1. Okay, what would your E1 be, Norman? What would your E1 be? Do you think it's easy to get E1? How would you get E1? Porche, you said E2. Please give me your answer for E2. If you say E2, Amara, you said S2. Give me answer and a reason. Norman, you said E1. Guys, I need this class to be very interactive this morning. So some of you that are just watching, it's not a TV, it's a class. Can we talk? Can we talk? Isa, can you please unmute yourself and quickly explain how you got 135? I want to hear your voice. Tell me how you got 135. Norman, I see you said 45 degrees corresponding.
Sir, can you hear me?
Yes, I can. I can.
Okay, sir. So the way you're gonna work out E2 is because co-interior angles are going to equal to 180 degrees and is supplementary, and SE is parallel to TR. So if you have to work it out, you'll say you change E2 to X, We'll say x plus 45 equals 180 degrees, and shift over, and your x will give you 135 degrees.
All right, thank you. Thank you. Thank you. Amara, do you want to? I want to talk to you too as well. You said S2 is 45, but I want to hear your voice. Amara, please talk to me. Unmute yourself quickly and then talk. Let's have something interactive. Amara Patel. Zainab, your hand is raised. Amara says she doesn't want to talk. Okay. Zainab, your hand is raised. Guys, Amara says she doesn't want to talk and then she smiles. All right. Zainab, your hand was raised. You have a question? Or it was a mistake? All right. Lovely. Madia, T2 is 135. Opposite angles of PAM. All right. So, guys, I think we're fine with this question already. And I like your reasons. So, this angle is, all right, we can say this angle is 45 as well. S2 45. Opposite angles of a parallelogram. And Porcher gave us a very, very good way to get E2 by using co-interior. All right, they are co-interior. So if this is 45, okay, Porcher, you don't need to change this to x, all right, because there's an x in the question already. What you need to do is to write this. Let me just help you in putting it down. E2 plus what's that angle? Angle R. All right, E2 plus R. Leave it as E2 plus R equals to 180. Co-interior. All right, and also tell us, don't just say co-interior. SE is parallel to what? TR. SE is parallel to TR. All right, so from there, E2 plus 45 equals to 180, and therefore E2 equals to 135 degrees. All right, and Madia just got T2. She said 135 opposite angles of a parallelogram. All right, so guys, you see that that question is done already. We already have all our angles. All right, any question? If you are okay, please let me know. Okay, 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 okay. And I'm expecting how many okays before we go to the next question? 30. We are 30, and I'm counting. 1, 2, 3, 4. Okay, now you've beat me, guys. I can no longer count. All right, but just want the okay. Oh, Sam, okay. Oh, Sam. All right. Who else in this SM class that is not talking to me? I need everyone to talk to me. Tasmia, I have not heard anything from you. Amara Sheikh, well done. Yumna, I need your okay if you're okay. Zidane, I need your okay. Abiba, how are you, Abiba? I need your okay if you're okay before we move on. All right, Haika, I need your okay. If you're not okay, I need to know. So I need everyone's okay. Thanks, Aliyah. Thanks, Sahira. Thanks, Amara. I'm checking. I know. Oh, Yumna, sorry. I think it went too fast. Okay. Smaya, Leonard, did you tell? Are you okay? All right. Good. All right, Zidane. Thank you. Ramiz, Noman. Okay. Nasira Mia, are you okay, Nasira? Mosa. Okay. Mosa, are you okay? Motham Habrams, are you alright? Is that question fine? Alright, everybody seems to be okay. Amina, good. Thank you, guys. That's such a wonderful thing. Lovely. Lovely. Okay, let's check another question here. Look at this question. All right, I'm sure you have it in your book as well. ABCD is a parallelogram, and we are told that FD is equal to DC. Remember, guys, once they start telling you all this information, start making annotations. Don't write in your textbook. All you can do is draw this out. All right, just draw it out separately. I always do that as well, but here I'm free to write FD is equal to DC, because once you start writing, it makes life very, very easy for you. FD is equal to DC, and DE is equal to 2DO. Hold on. DE, that's DE there, is equal to DO. Alright. But check something. We are told that DO is equal to X. That small part there is X. It means that if DE is equal to 2DO, can I then say DE is equal to, instead of writing DO, can I write X? So it means that ED is equal to 2X. That's all we have. By the way, we know it's a parallelogram. ABCD is a parallelogram. So, ABCD, let me use red. ABCD is a parallelogram. What do we know about a parallelogram? We know that opposite sides are what? Parallel. So, check this. A, B, C, D. This is parallel to that. And that is also parallel to this. Okay, beautiful stuff. Proof that BECF, where is BECF? That big box up there. B, let me use a blue. Proof that BCEF is a parallelogram. And to prove a parallelogram, remember what we need to prove? What are we proving? What are the properties of a parallelogram? What do we need to prove? Properties. Somebody talk to me. What do we need to prove? You must always know what to prove. Properties. Somebody talk to me. What are the properties that we need to prove here? Okay, we need to prove that diagonals of a parallelogram bisect. That's one. That's one. All right. There are so many. What else can we prove? What else can we prove? Opposite sides are parallel. Thank you. Opposite angles are equal. At least one pair is opposite. All right, guys. So I love the reason. So these are the things you need to look out for. You just don't answer questions. You look out for. It's almost as if saying this is the whole idea. You know where you are going. Now you need to find your way there. All right. Thanks. Two pair of opposite sides are parallel. Lovely. You need to know where you are going. If you know where you are going, it is easier to get there. All right. Good. I mean, you cannot be going to, you know, you are going to Durban, and you take a flight to Cape Town. You are completely lost. All right. Diagonals bisect each other. Thanks, baby. So those are the things that we are going to try to prove. Opposite sides are parallel. Opposite sides are equal. At least one pair is parallel, and so that's what we are going to prove. All right. Let's check something here quickly. Guys, for you to see this closely or clearly, I am going to try to draw out something for you. Euclidean takes time, so you need to consistently practice. This is F, this is C, and this is B. This is D. I don't know if you can. Oh, no problem. Isa, you cannot hear me again. Am I still audible, guys? Oh, all right. Lovely. Good. Okay. Awesome. Okay, thanks, guys. Now let's continue. Now, Shahina, your hand is raised. Shahina, hand raised. Do you have a question? Okay, lovely. Let's quickly finish this question. All right. Now, look at this. What theorem do you think we can pull out here? You know, we're given this, that is equal to that. And this, we're given that this line is parallel to this line. What theorem do you think we're talking about here? If you got how I extracted the information out, right? I just took that side of the triangle there and I extracted it for visibility. What theorem are you seeing here? This side here is equal to this side. Oh, thanks, Shahina. Midpoint theorem. Lovely. Thanks, Amara. Midpoint. Good, guys. Can I then say that FB should be equal to... Oh, no, we don't know this. Let's create a point here. Let's call it what? P. Let's call this point P. You are allowed to do that. Okay. Point P. Alright, my board is now doing some nonsense. Alright, point P. So can we then agree that FP is equal to PF according to our midpoint theorem? Let's put that down. Alright, so we are going to say FP is equal to PF, midpoint theorem. And is it okay to say that DP is equal to half CB? Do we agree? Do you remember the midpoint theorem? That DB is half of that. We constructed, if you remember that class. Alright, lovely. So we already have DP. Great. Now let's go check something here. So already we have this side saying it is half this side. Now guys, I want to do something else here. I'm going to extract another triangle for you. EFB. Look at triangle EFB. There, it's turned upside down. Let's check something with triangle EFB. This is what we have with EFB. Alright. I've got E, I've got F, I've got B. I've got the same line here, which is D, and we said this is P. Okay? Already we know that this is equal to this. That's what we proved earlier on. Do we agree? Let's check. Let's go back. So we proved that, let me use a blue, that this side is equal to that side. Are we okay? But we know, I don't know, I think it was Ramiz that said that the diagonals of a parallelogram bisect each other. Check something. The diagonals bisect. Can I then say ED is equal to DB? Do we agree that the diagonals bisect each other? ED is equal to DB. Good. I'm sure we agree. ED is equal to DB. I'm going to do this here. ED is equal to DB. What can we then say? Can we agree that this is another midpoint theorem? That if we have it like this, automatically DP will then be parallel to EF, and DP would be equal to half EF. Check that. DP is parallel. And what's our reason? Midpoint theorem. Do you guys agree with me? Do you guys agree with me? I want yes or no's. Yes or no's? Okay, good. Yes, you agree with me. Beautiful. Beautiful. I'm glad. I'm glad we're on the same page. I'm so glad we're on the same page. I want to just do something now while you are still responding. We have just 4 minutes left or so in this class. Just a second. All right, I want to extract this. Okay. All right. Good. We're back here. I want us to work with this diagram only now. Aha, got you. Okay, just. Okay, my dear, I'm going to read your question just now. I'm going to read. Yumna, you're saying, okay, let me read what you guys are telling me now. Sir, would it be correct if you used congruency to prove that triangle DFB and triangle DEC are congruent, and then prove that BE? Absolutely. Triangle DFB, let me see your triangle. DF. Okay. The right side. And DEC. Yes, you can prove that they are congruent, and if they are congruent, it is a parallelogram. Beautiful stuff. Beautiful. Beautiful. Sir. All right. Okay. Good. Yumna, I'm trying to get what you're trying to say there. But quickly, let's finish this, because there should be another lesson on your way. Remember what we've proven. We've proven that this line is now parallel to this line, right? And we've also proven that this same line is also parallel to this line. Can you now see that, number one, EF is parallel to CB? The top here is now parallel to that. Is that taken? 2 minutes? Do we agree? Because we prove, we did this, we call this P. We did this proof that DP is parallel to this. And we also proved that DP is parallel to that. It means EF and CB are parallel. Secondly, we proved that DP is half what? CB. The first time. We also proved that DP is half EF. Wait, DP is half CB. DP is half EF. Can we equate the two because both of them are equal to DP? Can I then say that half, check this, half CB would be equal to half EF? Do you agree with me? I hope you understand. Because both of them are equal to DP. Divide both sides by half. What do you have? CB is equal to what? EF. What have we proven? We have proven that one pair of opposite sides are parallel, and that pair of opposite sides is also what? Equal. One pair of opposite sides parallel and equal. Therefore, it is a parallelogram. There are so many ways to prove it. Like Madia is suggesting, we prove that these are congruent. All right. Guys, I have just about 63 seconds left. But what I did now, is it okay? I'm going to send this video clip over to you as well. But are we okay? Quickly. Let's answer in 20 seconds. 20 seconds. 20 seconds. Good. All right, guys, I'm going to ask you to just play around with 3, 4, and 5. All right. 3, 4, and 5, no man yebo. All right, 3, 4, and 5, question 3, 4, and 5. I'll do an offline video and send you the solution over the week, and then we end the whole thing about Euclidean, and I'll give you instructions. Tahira, your hand is raised. All right, thanks, Isa. So please do 3, 4, 5 as homework. I'll find time to send the video to you, and then we'll be done.